Hello everyone, today we will discuss about units and dimensions. First we will define the physical quantities. A physical quantity is defined as either by specifying how it is measured or by stating how it is calculated from other measurements. Now suppose, for example, distance is a physical quantity and you know that it can be measured by a meter stick. Similarly, time is a physical quantity and let us say it is measured by a stopwatch. So these are the physical quantities, distance and time, and we are telling here that how these are measured. The distance is here first measured by a meter stick. It can be measured by other way. Similarly, here time is measured by a stopwatch. Now let us say the other physical quantity is average speed, and you know that the formula for the average speed is that the total distance of the travel divided by total time of the travel. So here you can see that the average speed is calculated from the other measurements. It is equal to total distance of the travel divided by total time of the travel. Now we will define the units. It is important to know that how we can measure the physical quantities. So to measure the physical quantities, we must have units. Suppose length is a physical quantity and you know that how it can be measured. It can be measured in meter or kilometer or in centimeter or millimeter. Now there are two basic system of units. The first system is the SI system, or it is also called as the metric system. The other system is the English system. It is also called as the FPS system. F here foot, P here pound, S here second. And you also know that 1 foot is equal to 30 centimeter and 1 pound is equal to 400 gram. And you must also know that except the US, all other countries uses the SI system and it is considered as the standard system. Now in international system of quantities, there are three basic physical quantities in metric system, and those are length, mass and time. Length is represented by capital L and its SI unit is meter. It is represented by a small m. Now mass is the other physical quantity. It is represented by capital M and it is measured in kilogram and it is represented by kg. Then time is represented by capital T and it is measured in seconds and is represented by S. Now there are other units. Those are called as the derived units. The derived units can be written in terms of the units of the base quantities. Suppose here velocity or speed, you know that the formula for the velocity or speed is that it is equal to the length divided by time. You know that length is measured in meter and time is measured in second. So here the unit of physical quantity, which is velocity or speed, its unit will be meter per second, and these are called as the derived units because these are written in terms of the basic units. Meter is a basic unit and second is a basic unit. Meter is basic unit of length and second is basic unit of time. So here meter per second is a derived unit of the physical quantity velocity or speed. Now there are other physical quantities in international system of quantities, and these are the electric current. Its basic unit is ampere and it is represented by capital A. The other is thermodynamic temperature. It is having the basic unit Kelvin and it is represented by K. Then amount of substance, its unit is represented in mole and it is represented by mol. Then luminous intensity, its basic unit is candela and it is represented by CD. Now we will define the SI unit of the time and it is second. You know that. Now you must know that how 1 second is defined. 1 second is that time duration in which a cesium atom vibrates 9,192,631,770 in atomic clock. So 1 second is that duration. Next is 1 meter. It is defined as that distance in which a pure krypton atom emits orange light of wavelength 1,650,763.73. Next is 1 kilogram. 1 kilogram is defined as it is a mass of a cylinder placed in Paris having 39 millimeter height and 39 millimeter diameter, and it is made of alloy named platinum iridium. Now there are meter prefixes for powers of 10 and their symbols. Now here first column has prefix, then other is having symbol and then meaning. First is iota, it is represented by capital Y and it is equal to 10 to the power 24. Next is zeta, it is represented by capital Z and it is equal to 10 to the power 21. Then hexa, it is represented by capital E and it is equal to 10 to the power 18. Then peta is represented by capital P, it is equal to 10 to the power 15. Then tera, it is represented by capital T and it is equal to 10 to the power 12. Then giga, it is represented by capital G and it is equal to 10 to the power 7. Then mega, it is represented by capital M and it is equal to 10 to the power 6. Then kilo, it is represented by small k and it is equal to 10 to the power 3. Then there is hecto, it is represented by small h and it is equal to 10 to the power 2. Then there is deca, it is represented by dca and it is equal to 10. Now the other is prefix, symbol, meaning. Now it is yocto, it is represented by small y and these powers are in minus, it is 10 to the power minus 24. When it is represented by capital Y, it is 10 to the power plus 24. But here when it is represented by small y, it is equal to 10 to the power minus 24. Then jepto, it is represented by small z, it is equal to 10 to the power minus 21. Then atto, it is represented by small a, it is equal to 10 to the power minus 18. Then femto, it is represented by small f and it is equal to 10 to the power minus 15. Then pico, it is represented by small p, it is equal to 10 to the power minus 12. Then nano, it is equal to small, it is represented by small n and is equal to 10 to the power minus 9. Micro is represented by mu, it is equal to 10 to the power minus 6. Milli is represented by small m, it is equal to 10 to the power minus 3. Centi, it is represented by small c, it is equal to 10 to the power minus 2. Then deci, it is represented by small d and it is equal to 10 to the power minus 1. You have to remember these. Thank you.